Alright, so I'm going to review for a few minutes here how transiting works. So this is about how exoplanets can pass in front of their star and block out some of their light, and that's how we detect them. So Kepler 11 is a very special star that has several planets orbiting it. I believe we've got 6 planets that orbit the star. We've got planet B, C, all the way through G. So when a planet passes in front of a star, from our point of view here on Earth, the light of the star is dimmed or lessened because of that planet going in front of it. And it's called a light curve. And the light curve shows, the type of light curve can show us the type of planet and the speed of the orbit. So the curve is the dip in the light, as you can see here. The dip in the light of this planet is fairly shallow, and it doesn't take very long. It's not a very wide dip here either. So the shallowness tells us that the planet is not very big. Okay, so the size of the planet isn't very big because it's not blocking out very much light. It's also a fairly fast orbit because the length of time it takes for the dip to happen is also fairly short. It'd be wider if it were from here to here, which, as we can see down on planet G, has a very wide time, or a very long time that that passes in front of a star. So if it's a wide or lengthy amount of time, then that means the planet's moving pretty slowly. But we see here this planet's moving fairly quickly, and so are the first couple. Now, if the light curve is deep, or more light is blocked, that means the planet is big because it's blocking more light. So you can see C, D, and E are fairly big blocking, or more of the sun's light, more of the star's light is blocked because it's deeper. E is probably the deepest in the group. It reaches almost 0.9985. G is pretty deep too, but it just barely gets past 0.990. Actually 9990. But anyway, so that's how we can tell the size and speed of the orbit of the planet. So shallow means that it's not very big. Wide means that it's passing slowly. Narrow. Well, let me start that again. Shallow means it's not very big. Narrow means that it's moving quickly. Deep means that the planet is big and thus blocking more light. And a wide light curve, or long, which means it's taking a long time, means that the planet is moving slowly. So planet G here is pretty big. It's deep, so it's blocking a lot of light. That's what that means. It means it's blocking more light, so it's a deeper curve. And it's wide, so that means the planet's moving pretty slow. So planet G is probably a gas giant, and planet B is a small rocky planet, most likely. It's moving very fast, and it doesn't block very much light. So that's how we can tell the type of planet we're looking at when it comes to orbiting its star and the light curves and how they can be different.